All right, here we go with example 3. Example 3 gives us an equation. It also gives us a graph, and it gives us another gift, which is it's calculator active. So what does that mean? Well, up to this point in the course, there are three things you can do on the calculator where you don't have to show any work, and you can just use the calculator to get the answer. The first one is you can graph in an appropriate window. The second one is you can solve an equation and not have to show your work. You can just give the answer. And then number three, you can find the numerical derivative. You can find the derivative value at a specific point. Those are the only three things you can do on your calculator where they don't require you to show any work. So as we go through this, think about what are the things that we can use the calculator for where I don't have to show work and we can save ourselves some time. So 4 times between 0 and 2. A bug is moving along an x-axis. That means it's only moving left and right, with a velocity v of t equal to t squared times the sine of t cubed minus 1.5t. Find a of 0.7. Well, this would be the acceleration, and the acceleration is the derivative of velocity. So here's my velocity. We're going to have to find the derivative of this. Could I do the product rule? Sure. I have t squared times sine of t cubed minus 1.5t. I could find the derivative using the product rule, but they let me use my calculator. So why don't I just use my calculator? So we're going to find the derivative at 0.7 because the acceleration is the derivative of velocity. So I go to my calculator and I've already preloaded this. One thing I do want to point out, since I've read ahead in the problem, we're going to use this formula, this equation of velocity for two different reasons in two different cases. So I'm going to save that equation in y1. So this is another way that I don't think I've shown you, but we can definitely use it to save some time. So I've already typed in my formula into y1. So I go back to my home screen, and now I'm going to run the numerical derivative. So if you press math, option number 8, you can go down to number 8, or you could just press the number 8, and you're going to get this setup. So I have my formula in terms of x. So d dx means take the derivative with respect to x. And normally I would just type in the formula here, but since I saved it in y1, why don't I just call up y1? So I'm going to do alpha trace, and then there's y1, option number 1, select it. And so now the calculator knows that you're going to take the derivative of the equation in y1, and we're going to do it at 0.7. Not 0.7, but just 0.7. Press enter, and there's our answer. Negative 0.921. Remember, our answer needs to be accurate up to 3 decimal places. So you could just cut it off and say negative 0.920, or you can round it and say negative 0.921. Both will be acceptable and both are correct. But it has to be at least 3 decimal places. You can put more, but it has to be at least 3. So negative 0.921. So I come over here and I say, hey, I found the answer to my acceleration. A of, let's use this one, A of 0.7 is about negative 0.921. Awesome. I answered the first question, or the first part of the question. The second part of the question is talking about speeding up or slowing down. And remember, we said in the previous video that in order to show that a particle is speeding up or slowing down, the velocity and the acceleration have to be the same sign. Either they're both positive or they're both negative, but they have to be the same so that they can work in conjunction and make that object move faster, speed it up. Or they can be opposite signs. The velocity could be negative, the acceleration could be positive, or vice versa. Then they're going to work against each other, and that's going to slow down the object. So in order to figure out what's going on, I need to know what is the velocity doing at 0.7 seconds or minutes or whatever this is. V of 0.7. Now I need to find this. So I go back to my calculator, and remember we saved the formula in y1. So I go back to my home screen. I'm not going to look for the derivative. I'm just looking for the output, the y value, the function value, the velocity value at 0.7. So I'm going to bring up the formula, alpha trace. I'm going to choose option number 1. And I'm going to treat it like function notation. You know how when we do f of 3 or v of 3, here we're going to do y1 of 0.7. The calculator knows that you're using the formula that's saved in y1 and you're plugging in 0.7, and it's going to spit out the answer which is negative 0.318. Negative 0.318 is the velocity. And so now I have both measurements. Why do I need them? Because I need to tell whether they're speeding up or slowing down. So my acceleration is negative, my velocity is negative. So the bug is slowing down where at time 0.7 because the velocity and acceleration are the same sign or have the same sign or are both negative, however you want to phrase it. But the idea is that because they are both negative, they are working with each other and speeding. I'm sorry, not slowing down. They're speeding up. They're speeding up my object. I'm being a silly person here. They're speeding up the object because they're working in conjunction. Negative acceleration, negative velocity, it's going to speed it up in that direction. That's how we can use our calculator to maybe do things a little bit faster. Could I have taken the derivative using the product rule? Sure. Was it going to take a lot longer? Most definitely. And then there's also the probability that I will make an error and then I get the wrong velocity or the wrong acceleration if I take the derivative velocity. So use your calculator, use option number 8 under the math menu in order to take the numerical derivative. All right, go to the next part. Find any values of t in the interval between 1 and 2 where the bug is at rest. We had talked about what this means. At rest, that means the velocity is equal to 0. So I want to know when is this equal to 0? When is the velocity, which is that equation, equal to 0? Well, this is not a solve by hand situation. This is a look at your graph and see what's going on. And so I come to my graph and I notice, oh, well, it looks like it's 0 here and it looks like it's 0 here, but what are those values? I don't know. And so I'm going to come back to my calculator. Since I saved it in Y1, I'm going to graph it on my calculator. However, I am going to make the little change to my window. Remember, we only wanted between 1 and 2. And I'm going to put a no scale on that. And then I'm going to zoom in a little bit more. I'm going to go from negative 2y to positive 2y. And let's see what we see. So between negative 1 and 2, between positive 1 and 2, there are only 2 places where the velocity is equal to 0. We're going to find what those places are. There are different ways to do this. If you press second trace, you can do a 0, find a 0, and then that can help you figure it out. The way this works is you're going to move your cursor. Oh no. You're going to move your cursor until you're on the left side of the x-intercept of the 0. So I'm pressing it. You basically want to trap where you think the x-intercept is, where the 0 is. You want to trap it between these 2 lines. Once you go to the left, press enter and see how it draws that line. So now I'm going to move a little bit to the right of where you think the 0 is and press enter. And so the calculator is looking for the 0 in that little window, and this is the 0 at time 1.225. At time 1.225. But there's another place, right? We saw it in the graph that was given to us, and we saw it on the calculator. There's another spot over here. So now I have to do this again and move my cursor to the right. So I'm going to trace. I'm going to say, let's find a 0. So I'm going to move to the to the right, but I'm going to be on the left side of where the 0 is. Press enter and it's going to draw the line. And the calculator is going to look for a 0 in between those lines. Press enter. So see how my 0 is in between there. Press enter and it's going to find it, and it's at 1.801. 1.801. So at those two time measurements, my velocity is equal to 0. How do I know that? Because I'm looking at the velocity graph, and that's where the y, which is what the velocity is showing us, is equal to 0. Right here and right here. I'm using my calculator, though, to figure out the exact values, at least to 3 decimal places. We'll come in the next video. We'll do C and D, and then we'll wrap it up.